Hello guys, my name is Craig. Welcome to my main YouTube channel. Today we shall be looking at module 1 of the differentiation series, and this is the basics of differentiation. So to start off, what is differentiation? Differentiation is a process of finding the general expression of the gradient of a curve at a specific point. So this general expression, it is given a name. It is called the derived function or the gradient function, or you can call it the first derivative. So now let's look at the notation that we use when we are differentiating. So now for a function y is equal to x squared, we say dy by dx is equal to 2x. So dy by dx, this is the expression that is used to show the gradient function. So in other words, we're simply saying the gradient function of the function y is equal to x squared is equal to 2x. And we can also say for a function f of x is equal to x squared, f prime x is equal to 2x. So now with this example, f prime x will be the notation that is also used to show the gradient function. So in other words, we're simply saying the first derivative or the gradient function of the function of x is equal to 2x. So now we can come up with a general form of differentiating x to the power of n. So we say d by dx of x to the power of n would be equal to nx to the power of n minus 1. So now this becomes the general form of differentiating x to the power of n. So we are saying we drop the power n, then we multiply by x, and then we finally subtract 1 from the power. So for example, d by dx of x to the power of 7, in this case our power is 7. So we are saying we drop the power 7, multiply by x, then subtract 1 from the power of 7. So our answer will be 7x to the power of 6. This is what we get. Another example, if we are to find d by dx of x to the power of minus 2. So our power is minus 2. We're going to drop this power minus 2, then multiply by x, then finally subtract 1 from the power. So this becomes the power of minus 2 minus 1, which will give us an answer of minus 2x to the power of minus 3, like that. So there will also come situations whereby we have to differentiate multiples of x to the power of n. So for the differentiation of multiples of x to the power of n, we are saying d by dx of ax to the power of n is equal to, so what we simply do is that we take out the a, which is the coefficient of x to the power of n. Then we multiply it by the derivative of x to the power of n. So we are saying multiplied by d by dx of x to the power of n. And we say d by dx of x to the power of n will give us nx to the power of n minus 1. So in this case, we will get a nx to the power of n minus 1. For example, if we are to differentiate, say d by dx of 5x squared. So now what we're going to simply do is that we shall take out the 5, which is the coefficient of x squared, then multiply it by the derivative of x squared. So when differentiating x squared, our power is 2. We say to drop the power 2, multiply by x, and then subtract 1 from the power. So 2 minus 1, we get to the power of 1. So now if you further simplify this, we will get 10x. Is the final answer. And there are also situations when you have to differentiate a constant. So now, when differentiating a constant, let's look at what we have. So d by dx of a, which is a constant, we know that if a is a constant, then it will be ax to the power of 0. So we can rewrite this as d by dx of ax to the power of 0. So now, let's do what we talked about here. If we take out the a, we're going to say this is going to be equal to a times the derivative of x to the power of 0. So when differentiating x to the power of 0, we're going to drop our power 0, then multiply by x, then subtract 1 from the power of 0, so to the power of 0 minus 1. But what do we know? We know that a times 0 already gives us a 0. So now from this, we can say that any differentiation of a constant will give us a 0. So now let's move on to look at a couple of examples that comprises of a combination of sums and differences. Okay, so now, first example, say we've got a function y is equal to x to the power of 3 plus x squared minus 5x plus 6. And we are asked to calculate the gradient function, which is dy by dx. So dy by dx will imply that we are differentiating y with respect to x. So now what we shall do here is that we shall differentiate term by term. So now the derivative of x to the power of 3, we know that we drop the power 3. Then multiply by x. Then subtract 1 from the power of 3 to get a 2. Then plus the derivative of x squared, we are saying that we are dropping the power 2. Then we are multiplying by x. And then we are subtracting 1 from the power of the 2 that is already there. So we shall get x to the power of 1 minus. So now the derivative of 5x, we say we take out the 5. Then multiply by the derivative of x. We know this is x to the power of 1. So we drop the power 1. Then multiply by x. Then subtract 1 from the power of 1 to get a 0. Plus the derivative of 6. We know that when we differentiate a constant, we get a 0. So we just put a 0 there. So now let's simplify this. This shall be equal to 3x squared plus 2x minus 5. Because we know x to the power of 0 will just give us a 1. So this becomes the solution, which is the gradient function of the curve y is equal to x squared plus 2x, x squared plus x squared, x to the power of 3 plus x squared minus 5x plus 6. Now let's look at another example. So now in this example, it's just going to be a bit tricky, but we shall work on it. Alright, so now say we want to find the gradient function of the curve y is equal to x squared, open bracket, x to the power of 3 minus 4x. So now what do we see? We see that this is a product of x squared and x to the power of 3 minus 4. So now what we have to know is that for products and quotients, all the rules that we've talked about here, they do apply as long as we can multiply out, expand, or separate. So now we see that we can multiply throughout by x squared to get a term by term. So now if we expand, right, we're going to get x to the power of 5, right, minus 4x to the power of 3. Like this. So we've expanded it. But now, with this, we know we can differentiate term by term to get our gradient function. So we're going to say y is equal to d by dx of the first term x to the power of 5 minus d by dx of the second term 4x to the power of 3. Now let's differentiate. So this is dy by dx. So dy by dx is going to be equal to differentiating x to the power of 5. We are dropping the power of 5, multiplying by x, then subtracting 1 from the power of 5 to get a 4. Minus, now we are differentiating 4x to the power of 3. We say we take out the 4, so we're going to take out the 4, then multiply by the derivative of x to the power of 3. So now we're differentiating x to the power of 3. We are dropping the power 3, multiplying by x, then subtracting 1 from the power of 3 to get a 2. So now if we simplify this, we will get 5x to the power of 4 minus 12x squared. So now this would be the gradient function of the equation of the curve y is equal to x squared times x to the power of 3 minus 4x. Now let's look at an example of a quotient. Say we need to find the gradient function of the curve s is equal to t to the power of 4 minus t squared plus 7t over 6t squared. So now this is a quotient. But what do we know? We know we can put each term in the numerator under 6t squared. So now let's do that. We're going to say s is equal to t to the power of 4 over 6t squared minus t squared over 6t squared plus 7t over 6t squared. So now we know we can simplify each of these terms. So now s is equal to, simplifying the first term, we will get 1 over 6 t squared, because we know t to the power of 2 into t to the power of 4, we get a t squared. Then minus t squared is going to cancel with t squared, 1 over 6. Then, for simplifying 7t over 6t squared, we're going to get 7 over 6t, like that, right? And now we know we can rewrite this as s is equal to 1 over 6 t squared minus 1 over 6 plus 7 over 6 t to the power of minus 1. Right. So now we can find the gradient function because we know we can differentiate each term separately. So now ds by dt is going to be equal to the derivative of 1 over 6t squared minus the derivative of 1 over 6 plus the derivative of 7 over 6t to the power of minus 1. So now let's differentiate these step by step. So now for the derivative of 1 over 6t squared, we say we take out the 1 over 6, then multiply by the derivative of t squared. So now differentiating t squared, we are dropping the power 2, multiplying by t, then subtracting 1 from the power of 2 that is already there. So we get t to the power of 1. Minus 1 over 6. If we differentiate a constant, we get a 0. So there we're just going to get minus 0. Plus the derivative of 7 over 6t to the power of minus 1. We're saying we take out the 7 over 6, then multiply by the derivative of t to the power of minus 1. So now we are dropping the power minus 1, multiplying by t, then subtracting 1 from the power of t to get a minus 2. So now if we simplify this, right, 2 there, we get a 3 there. So we shall get 1 over 3t That's a 0. And then plus and the minus will give us a minus. So 1 over 3t minus 7 over 6 t to the power of minus 2. So this is going to be the derived function or the gradient function of the k of s is equal to t to the power 4 minus t squared plus 7t over 6t squared. Alright, so this was module 1 of the differentiation series. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.
Weezy out of here.